All right, hello everybody. Today we're going to take a look at a little bit more at confidence intervals. So in the last lesson in 7.1, we just looked at the basics of confidence intervals and the error associated with those. And what we're going to look at today is how to calculate confidence intervals and how big your population size needs to be in order to establish a certain confidence interval. Okay, so some notation. If we have a given percentage for a population, we're going to use the variable p for that. This is pronounced p hat. It's got the little symbol on the top, and that is the proportion of a sample that meets a certain characteristic. And then Q, so we have P is calculated as X over N right here. So for example, if you had a sample population and you wanted to know the proportion of the population that has black hair, and in your sample you had, let's say, 36 out of 60 people in your sample had black hair. So you would calculate that 36 divided by 60, and that is 0.60, and so that is p hat for that given population. So X is the number of people that have the characteristic, is what it says here, and 60 is that's the number of people in the sample. Okay, so that's 0.6 or 60%. Okay, and then Q, if we calculate Q for the same thing, Q hat would be number of people in the population, or in the sample, 60 minus the number of the people with the characteristic over 60, and that is 24 over 60, which is 0.4 or 40%. And so you'll notice that these two add up to 100%. And so an easier way to calculate Q hat is to just do 1 minus P hat. So P hat and Q hat have to add up to 1. And so once you calculate P hat, then just subtract it from 1 to get Q hat. So those are parameters that we're going to need in doing some of the calculations later today. Okay, so in this first example, if we have 177 people in our sample, 80 of them have the given characteristic, then P hat is just 80 divided by 177. And so 80 divided by 177 is about 0.451977. Q hat would be 1 minus 80 over 177. And that is 97 over 177, or about 0.5480. This says round to 3 decimal places. So for the first one, I would say that's about 0.452, and this one is about 0.548. Okay, so now here comes the formula. Now that we understand how to calculate P and Q, or P hat and Q hat, we can generate a confidence interval given a certain percentage. And so let's see. So in this formula, there are some things we already talked about what P hat is. We just did that, and we already talked about Q hat, which is used up here. So P hat and Q hat are there. We already talked about what N is. N is your sample size. What's new is this Z sub alpha over 2. So that's really small. It's saying Z, the Greek letter alpha over 2. And what alpha refers to is the tail at the end of a confidence interval. So that is alpha, and or the sum of the tails. So yeah, it's actually the sum of the tails. So this area and this area together make alpha. And so if we just take one of those, if we just take our interval like this area right here would be alpha over 2. And so we're trying to calculate the z value right here associated with alpha over 2. And so if we say C is our confidence value, meaning if we want 90% confidence, if we want 95% confidence, that would be C. And C for confidence. And then alpha is always 1 minus C. And then Z of alpha over 2 is the Z-score for 1 minus alpha over 2, because that gets you all of this, which is what we want. Okay, so in order to use this, n times p hat and n times q hat are each greater than or equal to 5. If not, then we need a larger sample. And in order to find a confidence interval, the sample needs to be a random sample. And the conditions for the binomial experiment are satisfied, which means that, as we talked about earlier, P and Q have to add up to 1, and there are only 2 possible outcomes. It either happens or it doesn't. So with the black hair example, we have people that have black hair and people that don't have black hair. And so there's only 2 possibilities. So that's what they mean by the conditions for a binomial experiment. Okay, and so let's go ahead and take a look at this example then. So a survey found that 32% of people said they would get no work done on Cyber Monday. Find the 95% confidence interval of the true proportion. So 32% is just what the sample said, but for the entire population of the country, for the whole population, we don't know that the value is 32, so we want 95% confidence interval that this that's going to be surrounded by 32. And so first we calculate our C value. So C is equal to, since we're trying to get a 95% confidence interval, C is equal to 0.95. And so then alpha is equal to 1 minus 0.95, which would be 0.05. And alpha over 2 is 0.025. And so we're looking for the Z value that is associated with, this would be 97.5, because, or 0.975. It is 97.5%, but we will want 0.975 because this is alpha over 2 right here, which is 0.025. And so we can use our calculator and use the inverse norm. And we want 0.975. And that is associated with Z equals 77, let's see. Sorry, 1.96. That's, I think, one that we calculated earlier today, 1.96. And so now using the formula that we have up here, we're doing p hat minus that z value that we just calculated times the square root of p hat q hat over n. Okay, so P hat, we didn't calculate P hat yet. So P hat is 0.32 from our sample. And so that means Q hat is 0.68. It's 1 minus 0.32. And so now we have our lower limit is going to be P hat, which is 0.32 minus this Z value that we got, 1.96, square root of P hat Q hat, so that's 0.32, 0.68 over N. N in this case is 1,100. We have 1,100 US adults that were surveyed. That is going to give us our lower bound for our confidence interval. And so looking back at the formula again, so this is what we did. We did P hat minus, this is our Z sub alpha over 2, which turned out to be 1.96. Then we did the square root of P hat Q hat multiplied divided by N, and that's less than P. And now on the right side of the less than sign is, again, P hat, but this time it's plus the same expression that we just calculated. So here it's going to look very much the same as what we wrote over here, except this is going to change to plus. So this is 0.32 plus 1.96 square root of 0.32 times 0.68 over 1,100. Okay, so in our calculator, 0.32 minus 1.96 times the square root of 0.32 times 0.68 divided by 1,100. Now I right arrow to move out of the radical and press enter. So that gives us 0.2924. Is less than P is less than. Now if we want to type the same exact expression but with a plus, I don't have to retype all of it on all the TI calculators. If you just press second enter, it retypes what you just had, and you can go back in and edit. So I'm going to edit this expression. I'm just going to go back and change that to a plus. So again, that keystroke was second enter. So the blue second button and then the enter button down at the bottom right, and that retypes what you just got done typing and allows you to go in and edit it. So I changed that to a plus, and now it says 0.3476. So our true percentage of people that will not get any work done on Cyber Monday is somewhere in between 29% and 35%, roughly. Okay, so that's what this confidence interval means. It means with 95% certainty, we can say that the true percentage, even though our sample said the percentage was exactly 32, that only represents the sample. So this means our total population, that's what P means without the hat, the total population proportion is somewhere in between 0.2924 and 0.3476. So we can be 95% sure that that's the true interval. Okay, so now let's take a look at example 3. This time we have a random sample of 215 college students, so that's N. They were asked if they believed that places could be haunted, and 91 of them said yes, that is X. So from that we can calculate P hat. P hat is 91 over 215. And so that is 0.4233, and Q hat is 1 minus 0.4233, which is 0.5767. Our C value is, reading on, it says, estimate the true proportion of college students who believe in the possibility of haunted places with a 90% confidence. So C is 90%, so 0.9. And so that means alpha is 1 minus 0.9, which is 0.1 or 0.10. And alpha over 2 equals 0.05. So our Z value for alpha over 2 in this case is, we're going to do inverse norm. 1 minus 0.05 is 0.95, 0, 1. And so let's see what our calculator tells us for that. Inverse norm, 0.95. And it says that is 1.6449. And so then I believe now we have enough to calculate our interval. So remember, it's p hat on this side, so 0.4233 minus our Z value, which is 1.6449, square root of, I need a little bit more space here, 0.4233 times 0.5767 divided by n. N in this case was 215. And then we're going to have the same exact expression over here, 0.4233, except it's now a plus 1.6449, square root of 0.4233, 0.5767. I wrote 9 on this one. It should have been a 7. And then divided by 215 again. So it's the same exact expression, except one has a minus and one has a plus. It says to round our interval to at least 3 decimal places. And so if we calculate this, that is 0.368, rounding to 3 decimal places. And then remember on your calculator, if you press second enter, you can just go back and change that to a plus sign, and that is 0.479. And so we know with 90% confidence that the true percentage of college students that believe in haunted places is somewhere between 36.8% and 47.9%. So that is the confidence interval that we're looking for. Now, one of the things that we didn't discuss with these last 2 examples was, do we have a large enough population? And so remember, when we do n p hat, that should be bigger than 5, and n q hat should be bigger than 5. So let's check that and make sure that we have enough people in our sample. And so for this one, it's n is 215, p hat was 0.4233, and 215 times 0.4233 is 91, and that is definitely bigger than 5. So that one works. And then if you do 215 times 0.5767, that's going to be even bigger. That's 123, which is also bigger than 5. Okay, so it's a good idea to check and make sure your population size is big enough. If we go back to example 2, we could check the same thing But in this case, we have 1,100 people in our sample, so that this should not be a problem at all. If I do 1,100 times P, which was 0.32, that is definitely big enough. That is 352, well bigger than 5. And if we do the same thing with Q, it's going to be even bigger than that. So the next thing we're going to look at is how to calculate the minimum sample size if we need a certain confidence interval. What is the minimum sample size that we would need to achieve that confidence interval? And so we use this formula for that. We've already talked about what n represents. That's what we're going to calculate here, which is the number of the sample size, number of people in the sample. And then p hat and q hat are no different. We've already talked about z sub alpha over 2. The only thing new here is e, and that is our error, meaning the how far above and how far can we go above and below the middle. And so we want our, let's look at example 4. And so that is, we'll label that as our error. And so in the example 4, we have a sample study where there are 21% of 200 people surveyed that were widows and over age 55 in the study that were widows. Okay, so round up your answers to the next whole number for the following questions. How large a sample must you take to be 90% confident? So that's our C value. This is our P hat. That's our we're saying 21% of the people had this characteristic that they were widows. And we want to be 90% confident that the estimate is within 0.05 of the true proportion. Okay, so that is our E value. E equals 0.05. Okay, and so I think we have everything we need to do the calculation. We identified that P hat is 0.21, which means Q hat would be 0.79. And we said E is 0.05. And what we need is Z sub alpha over 2. So since C is equal to 90 or 0.90, then 1 minus 0.90 is 0.1. So that's alpha. And so alpha over 2 would be 0.05. So this is going to be just like the last one we did. Our Z sub alpha over 2 is going to be inverse norm 0.9501, and that turned out to be 1.644. When we did it in the last one, it was 6449. Okay, so that is our Z sub alpha over 2, and so now we have everything we need. So to calculate the minimum sample size, we're going to have P hat, which is 0.21, times Q hat, which is 0.79. Then we're going to multiply Z, our Z value was 1.6449 over 0.05. We're going to square that. And so that is 0.21 times 0.79 times parentheses 1.6449 divided by 0.05. Close the parentheses, square it, and enter, and that gives us 179.55. 179.55, and we always round up, as it says here, if necessary, round up to obtain a whole number. we're talking about the minimum number of people that we want to survey, so it does make sense to round up to 180 people minimum. So we need to have at least 180 people in our survey to be confident that the true percentage is off by no more than 5%, 0.05. Okay, so that's our minimum sample size is 180 people to have that confidence. Okay, so for that one, we knew p hat was 0.21 because they had done this preliminary survey of 200 people. Now, let's say they hadn't done that preliminary survey, then how many people would we need to survey? So in that case, it says up here, when if p hat is not known, use p hat equals 0.5. So that's what we're going to do here. So we're saying if no estimate of the sample proportion is available, then we're going to use p hat equals 0.5 and q hat equals 0.5. What that does is it makes our n value as large as possible. So we're going to use the same formula, but here we're going to use 0.5, and here we're going to use 0.5, and then the rest of it's the same. Okay, so I'm going to use the same trick on the calculator, which is, so if I press second enter, then I'm going to scroll over and just change what used to be 0.21. I'm going to change to 0.5, delete the extra digit, and then change 0.79 to 0.5, delete the extra digit, and press enter. That gives me 270.57. And so we would take that and say at least 271 people. So that's the minimum sample size. If we didn't already have this preliminary study that gave us an idea of what the p-value is, then we would assume that p is 0.5. Now, another thing to note is this answer is very accurate. We used a calculator for all the steps along the way. But one thing I noticed is that when we use the Connect Math, it's using values from table E instead of using all the decimals that I was using. So they're when they calculate this, they're doing 0.5 times 0.5, and they're just using 1.65. And that changes the answer a little bit. So when we do 1.65 divided by 5 and square it, we get 272.25, and that is going to round up to 273 people. And so if you're using a calculator through the whole thing and Connect Math doesn't accept your answer, try using fewer decimal places, because when you use table E, it has everything to the nearest hundredths place for the Z values. And so if you, that's one thing throughout this whole lesson, if you're not getting the correct answers, you might just use the values from table E instead of using your calculator just for the Z values. And so using 1.65 gave us the answer that Connect Math was looking for, which is 273 people. So that's it for today's lesson. Everyone have a great day.